Section 5.1, Introduction to Polynomials, might be, just might be, the easiest questions you will receive all grade 9. I don't think you'll get much more easy than chapter 5.1. At least most of the questions are pretty simple. As long as you know your vocabulary, life is good. We started here on question 3. It says, give 2 examples of a polynomial that satisfies all statements. So it has to be all 4 of these things within the polynomial. So right away, consists of 2 terms. So we know that the polynomial I'm going to make in both cases are going to be what type of polynomial? That's right, a binomial. They have to contain 2 variables. So let's just start with a binomial that has 2 variables. Well, there's one right there. There's the simplest binomial I can think of that contains 2 variables. So far it meets this criteria and it meets this criteria. But does it meet this criteria, having a degree of 2? No, it doesn't. Because the degree of a binomial is determined by, of the 2 terms, the term that has the highest degree. And both of these have a degree of 1, so that doesn't work. But we can change that, can't we? One of these, we can simply slap an exponent of 2 on it. And now this term has a degree of 2, this has a degree of 1. So that entire binomial now meets the 3rd criteria. So we have 2 terms, yep. We have 2 variables, yep. We have a degree of 2, yep. As this one of the terms has a degree of 1. Well, fortunately enough, that term already has a degree of 1. And it also has to have a coefficient of 1. Now remember, a coefficient is how much of x we have. So if I had 2x, the coefficient is 2. If I have negative 3y, I have a coefficient of negative 3. If I have plus y, the coefficient that's not written is actually 1, because how many of the y do I have? I just have 1. So therefore, this, and this are all met with this one expression of x squared plus y. Now I'm going to try and do another one and see if I can make it happen. So xy plus 1. Does that have 2 terms? Yes, it does. Does it contain 2 variables? Yes, it does. Does it have a degree of 2? Yes, it does, because the x has a 1, the y has a 1, has a degree of 2. The only problem is, does one of those terms have a degree of 1? It does not, because this has a degree of 2. This does not have a variable, and therefore has a degree of 0, not 1. So that didn't work. I was so excited, but it didn't work. But we're just going to make, how about x squared plus y squared? Does it have 2 terms? Yes. Does it contain 2 variables? Yes. Does it have a degree of 2? Still does. Does one term have a degree of 1? Ah, son of a goat. No, it doesn't. Because that doesn't have it. Well, what if I do... I can't even think of another one anyway. Does anyone have another one? My brain's not working right now. Who has a different one? Yes, what do you have? Ah, aren't you intelligent? X plus y squared, of course it does. Well done. That is another example. I don't know if there's many other ones than those 2, though, is there? I think those might be the only 2 that meet all 4 criteria. Interesting. Question 4 says, when is it acceptable not to write a 1 in an algebraic expression? Well, there's 2 answers for that. In this case, it is acceptable not to write a 1 for 2 places, because 1 exists that I didn't write twicely in this particular expression. The first place, it actually is a coefficient of 1, but I don't need to write that coefficient. And it actually is an exponent of 1, but I don't need to write that. So the answer is, it is acceptable not to write a 1 if the coefficient is 1 or if the exponent is 1. You don't have to write it in those 2 cases. When must you write the 1? The answer is you must write the 1 if the 1 is your constant, right? It's important that you write the 1 if it's a constant term in your algebraic expression. But in all other cases, you do not have to write the 1. Question 5 says, for each expression, to identify the number of terms and whether the expression is a monomial, binomial, trinomial, or polynomial. Well, in A, we have, I'll grab my highlighter, we have 1 term, we have 2 terms, we have 3 terms, so we call that a trinomial. In the second one, we just have one term because there are no addition or subtraction signs. So therefore, it's a monomial. In C, we have 1, 2, 3, 4, all connected by addition, addition, and subtraction. So we have four terms. We will call that a polynomial. And in D, we just have the number 8. Oh, that's not a highlighter. We just have the number 8, or debate is on whether it's a constant or just a number. But that would be called a monomial because it's just one term. Question 6, what are the number of terms and what is the name for the expression? N is a one-term expression. There's one term, and it's called a monomial. I'll just put mono because I'm lazy. B, we have 1, 2, 3, three terms, and it's called a trinomial. C just has one term, and it's called a monomial. And D has two terms, and it's called a binomial. Now, would it be wrong if you call this a polynomial? No. Would it be wrong if you call this a polynomial? No. Because polynomial, by definition, is just more than one term. So binomials and trinomials are actually polynomials, but they just have special prefixes of bi and tri to be specific about how many terms there are. Question 7. Refer to the polynomials below to answer each question. Which ones of these are monomials? 6x is a monomial because it just has one term. Negative 15 is a monomial, and those are the only two terms above that are monomials. Which ones are trinomials? 7 plus a plus b is a trinomial, and that is the only trinomial. And the last one, which have two terms. Another way you could have said that one is which ones are binomials. You could have said that instead. They wanted to make sure your understanding is totes okay. Therefore, we would have 3x minus y, two terms, binomial. 4c squared minus cd is two terms, a binomial. And that's it. Those would be the answers for 7. What would this one be called again? Just out of curiosity. What's that just going to be referred to as? A polynomial. I don't know if a quadrinomial is actually a thing, but we should make it a thing. We'll call it a quadrinomial. It seems reasonable that would be a thing. Question 8, for each polynomial, what is the degree and the number of terms? So here we have one term, two terms. And remember, the degree of that is determined by each term's individual degree. 4 has a degree of 0. B has a degree of 1. So the entire binomial has a total degree of 1. FG is a binomial, so it's a binomial with two terms. This has a degree of 2 because the invisible 1 exponents that we just talked about. And G, the variable in the second term, just has 1, so its degree is 1. And therefore, the degree of the binomial is not 3, but the entire binomial has a 2 degree, or a degree of 2, because it's the highest degree term. Trinomial, 3 terms, degree of 2, degree of 2, degree of 2. The highest degree term, well, they all have degrees of 2, so the whole thing is a degree of 2. Question 9, same question. State the degree and number of terms. 2 terms, it's a binomial. Degree of 2, degree of 0. Therefore, it has a degree of 2. 1, 2, 3 terms, so it's a trinomial or a three-termed expression. Degree of 2, because k has an exponent of 2. Degree of 1, because the variable has an exponent of 1. Degree of 0, because there are no variables. So the degree for the entire polynomial is 2, the highest degree term. And finally, this monomial, it's a monomial or a one-term expression. There is no variable, so therefore it is a degree of a zilch, 0. There is no degree for terms that do not contain variables. Question D. Refer to the polynomials below to answer each question. Which ones are binomials? 2 terms, 2 terms, 1 term, 2 term. 2x squared minus y squared is a binomial, comma, 1 term, 2 term. 2 plus p is a binomial. That's the only 2 that are there. Which ones have a degree of 2? Well, 3b squared is a monomial, The variable b has an exponent of 2, so it has a degree of 2. Degree of 0, degree of 1, that does not have a degree of 2, so we can't include that one. 4st has a degree of 2. T has a degree of 1. 1 has a degree of 0. So that one, 4st plus t minus 1, has a degree of 2 as well. And finally, x has an exponent of 2, so its degree is 2. Y squared is an exponent of 2. So therefore, that term, 2x squared minus y squared, that binomial, has a total degree of 2 as well. Question 3, what is the variable in the monomial? Well, this is the only monomial. What's the variable in 3b squared? The variable is your letter. The variable is b, just b. And finally, which polynomials have a constant term? The easiest way to determine a constant term, the easiest way to determine what your constant term is in the expression, in the polynomial. It is the term that does not contain a variable. It is the variabled term, or the term that does not have a letter. This does not have a term without a letter. It just has one term, and that has a letter, so that does not have a constant. This has a term with no variable. 2 is just a term, so therefore 2 plus p contains a constant. The constant is 2. 4st, that is not a constant. T is a variable, it's not a constant, but minus 1 is a constant. So 4st plus t minus 1, that is your constant. And the last one has a variable. There is no constant term for 2x squared minus y squared. We're nearing our end of our time, so we got about 4 more minutes here. Pictures. It says, what expression is represented by each set of algebra tiles? So this is an x and this is an x. So algebraically speaking, if you want to say you have 2 of them, you say you have 2x, or whatever x value this is. Let's say it's 10. Let's pretend it has a value of 10. If you have 2 of them, you would take that 10 value and multiply it by 2, and that would be 20, which is what the value of all of those x's would be. But we just say 2x is what this represents. That's the term. This is minus 3. So that minus sign, or that negative 3, actually becomes a minus symbol, and we end up with a binomial of 2x minus 3. This is x squared. We only have one of it. Remember, we said before, you do not have to write a coefficient of 1 if it is a 1x squared. If you write it, it just means you're a silly goose. This one here, those are negative x's, so we're going to put 2 of them, so minus 2x, or negative 2x. And that's a positive 1. So it's our constant term, plus 1. We have x squared minus 2x plus 1 is what that picture says. And finally, the last one, C. This is a negative x squared. Remember, you do, likewise with 1, you do not need to write a negative 1 coefficient. It's a negative 1x squared, or negative x squared. It's plus 3x, because 1, 2, 3 positive x's. And it's a minus 2 for your constant term. So there, that picture would be representing the trinomial negative x squared plus 3x minus 2. Skip 12, go on to 13. It says model each polynomial. The x squared tile is your big old x squared tile. That's this one, done. A positive x is just one of these rectangular ones shaded in. That's a positive x. And a minus 1 is that small little one like that. So that trinomial is represented with that picture. 3 x's would be 1x, 2x, 3x. Done. Positive 2 would be positive 1 and positive 2. So this one would be 3x plus 2. And finally, negative 2x, since it's important that 2x would look like this, right? 2x would be like that. So negative 2x is the exact same picture, showing the opposite, but you don't shade it in. So negative 2x is just 2 x tiles not shaded in. Question 15, represent each of the following with a diagram. So any binomial, so you're going to have different ones than me. I'm going to just write the binomial first. I'm going to put x plus 1. That would look like an x and a positive 1. Now, most of you, if you were smart, that's probably the one you did. Something like that, probably. A monomial with a degree of 1. The easiest one I can think of is that, which would be this as a picture. But you can have different ones as well. That's a degree of 1. A monomial with a degree of 2. Okay, so I need an exponent of 2 with a coefficient of 9. So the easiest one you could possibly think of, degree of 2, coefficient of 9, would be that. And it's a pain in the patootie to draw it, but you have to draw 9 x squared tiles. The advantage of having a smartboard. I could copy and clone it if I needed to, but that would be what 9x squared looks like. It has a coefficient of 9 and a degree of 2. And finally, the last one, D, polynomial with 4 terms and a degree of 2. So I'm going to go x plus y plus x squared plus 4. There are 4 terms, an x, a y, an x squared, and a 4. 4 terms, 1, 2, 3, 4. And the degree is 2 because the largest degree is the x, so it's going to look like x. Oh, we didn't talk about what y's look like, did we? Oh, well. A little shorter, same thing. X squared, wonderful, and positive 4. There we go. That's a y tile. The length is y, the width is 1. Therefore, it'd be called, the area is y. Question 16, use your knowledge of algebra tiles to answer the following questions. How are the dimensions of a 1 tile and an x tile related? Well, if I put a 1 tile right underneath here, remember the length is 1, the width is x, therefore the area is x. The width is 1, the length is 1, therefore the area is 1. They are the same measure. They are both the length of 1 when we talk about the length of the x tile's width is 1 and the length of a 1 tile is 1. B, the rectangle shown is forming the x squared tile and 3 x tiles. What is an expression for the length of the rectangle? So what is this length right here? It would be an x and a 1 and a 1 and a 1, or the length would be x plus 3 for the length of that rectangle. And we're going to stop it there, and I'll make a separate video with the rest of them later.